problem, and I always like to say open is not just open, but open and disaggregated. Right? That's the premise of unbundling the RAN ecosystem. When we start looking at the RAN in the context of 5G networks, very important aspect that that comes to our mind is that there's a significant amount of intelligence that can be built on top of what you build in terms of infrastructure. So it was extremely important in the early years of RAN evolution to open up the interfaces that allow you to build the intelligence on top. So really, fundamentally, if I look at it, the most important and impactful aspect of the RAN that we will see in the coming years, and that again is from the fact that once you have open interfaces, your ability to build a lot more AI-driven automation, which is the premise. So those are two premises of open RAN that we have been working on. Right? Fundamental premise was when you have a diversified supply chain diversity in your procurement, and there are a lot more vendors supplying the same similar components, you have a choice, and therefore it brings down the cost. That was one premise. The second premise was to bring down the capex was that everything will run on off-the-shelf hardware. Before the 5G ecosystem and open RAN ecosystem started to come, everything used to be built on the custom hardware, and it continues to happen in a closed RAN scenario. Everything is based on custom ASICs, custom hardware. The premise of open RAN again was to be able to use off-the-shelf hardware, and therefore right on to the economy of scale of the open hardware that is going on. So the capex is taken care of. In terms of demands, right? We have to see as we go along as to what is the realization that has happened. The OpEx, which is the hardest part of the RAN, open RAN premise, right? For us to be able to say, has it been proven? The OpEx really starts to show up when the networks of scale are connected. On a small scale networks, the OpEx efficiencies are not so visible. So there is a premise and there is a belief that once you open up the interface, start to do the operational automation, the cost of maintaining the network over the lifetime will go down. And therefore, there is a significant amount of innovation that needs to take place. And that's where HFC as a company is looking to invest. We have been building radio units, we've been building integrated small cells, we've been building indoor and outdoor version of the same, we've built CPs. But we really start to see where the impact that we want to see in terms of innovation will start to show up through the open interfaces, building the intelligent layers of automation.
Thank you, Manish. I'll now ask Venkat Subbaya to give his view on Open RAN.
Yeah, this is Subbaya representing the Readiness Technologies. See, one of the things, like say, why does even the ORAN came into existence? See, traditionally, right, all the tier 1 and tier 2, the telcos, right, one of the biggest challenges for them was the network is a black box for them. The bottom line is, like said, they want to manage the network, they want to see what's really going on. But it was under captive from the tier 1, tier 3, tier 2 vendors, like you can say, Ericsson's, whatever you call, right? That is the biggest challenge for them. The telcos would like to see the more of what you call openness, be it hardware, be it software. That is one of the things. Obviously, the bottom line is like they wanted to make the cost down compared to what traditionally they are giving a lot of money to the tier 1 and tier 2 vendors. So how do you make the cost down? Obviously, the more and more participants from the OEMs, so that the more volumes can be created and you will get the lot of cost benefit to the telcos is concerned. Then another challenge what telcos will really face is the integration. The one of the biggest challenges for the telcos was the like say as the other panelists clearly told that we have the elements called like a ORU, OCU, ODU, and the obviously core is the external part of it. The going forward, like say more vendors are coming into picture, then the more integration happens off the shelf with the both with the labs and their in the premise of the telcos, which will lead to the explosion of the cards hardware, and that bottom line will hit where the cost of the equipment will definitely goes down. Okay, we all recommend to go in the direction being like say maybe as far as me is concerned, tier 2 tier 3 vendors are concerned, we prefer to go with the more of the cards hardware. Then other thing is the what you call more innovation, more integration happens, and we can quickly put a solution. See, when I speak to the most of the telcos, right? If you want to develop a feature or a small or big feature, right? The turnout of the feature was almost like a 6 months to a year. Even a few lines of code in technical terms to which translates to a good feature, right? To give a feature to the telcos, the tier 1 and tier 2 vendors will really take a long time because of whatever the legacy they have. So we believe that with the ORAN architecture, where it has been broken into pieces, right? We can definitely bring down the not only cost, the feature content also. That's what I can say. So then the other aspects, what it comes from the what you call, what are the challenges as for the ORAN is concerned, even from the network, the vendors are concerned. I definitely believe that few things I would like to bring it out. One is interoperability. That means more and more the labs has to come into picture where we'll put all our equipment and interrupt well before we take it to you as a what you call as you being a tier 2 tier 3 operators telcos the ISPs, right? We would like to do the much more integration before that. That bottom line is translates to good cost. Then other things is there is a good initiative coming from the government of India, primarily like say encouraging the MSMEs and startups to develop a small piece of the ORAN equipment so that we can deploy. See, if, as a small vendors to start with, right? If you go to the big telcos, it may be a difficult job, but being a ORAN vendor, it is not that hard. And at the same time, if you are like a telco which is like a tier 3 telco, like you may not some cases you may not get the audience from the big tier 1 vendors. So it may be good for you too to come back to us to provide a bits and pieces solution. At the same time, it is which has been well integrated among the MSMEs here sitting here. Okay, yeah, that's it from my side. Thank you.
Thank you, Subhaya. Just after everyone finished their opening remarks, I'm going to open it up to the audience right away. So be ready with your questions on whatever you want to ask. If you want to direct it to particular person, please do so that you know that I want to make this more participatory. Now, next over to Balaji Rangaswamy for his view on Open RAN.
Thanks. Thanks, Kumar. So I'll start by talking about Open RAN by taking an analogy from a totally different field. Bear with me for a couple of minutes, please. My son is into gaming big time. And serious gaming started with an Xbox 360. And then after some time, the games would not perform very well. There are some new games that are not downloadable on the Xbox. And we did some research, and then we decided that the PlayStation is the better equipment. And then about a year into the PlayStation, again, the games are just not performing enough. You can only buy games from the Sony PlayStation store, and there are a lot of restrictions. Finally, because he's so much into it, he did a lot of research, and he came to the conclusion that he has to set up a gaming console himself. So he picked the processor, he picked the graphics card, he picked the operating system, picked the motherboard, and built a full gaming system by himself. And now I've not had to worry about buying him a new gaming console for about 4 years now, and it's still going strong. It's exactly the same thing, the way that I look at Open RAN, that you probably buy an integrated box, the equivalent of an Xbox or a PlayStation, and you have to buy the applications from the same vendor. It's a black box, you don't know how it will scale, and there are a number of different constraints. With Open RAN, the vision that I see is you could put together the hardware of your choice based on exactly what you want to do with the hardware, put the telco software on top of it, and put exactly the radios that you need for your application. So in that context, the word disaggregation, unbundling, decoupling, all of them apply. The ability to put the software on any hardware platform of your choice, put it either in the cloud or at the site based on your deployment, I think is one of the most powerful changes that this approach brings. The other major one that I see is that you build a radio exactly that suits your needs. Earlier, when I started my career, there were only macro base stations, and there would be one radio which is probably 40 watt and above. When I started my career 25 years back with GSM, with Nortel, and then this concept of we want to deploy smaller cells with radios on rooftops, and then the concept of micro base station came. And then the indoor coverage took off, and then we saw all the major vendors. I was involved in this. Can we do a pico base station, right? The smaller one. About 15 years back in US and UK, due to tower regulations, they were not able to place towers very close to the homes in the suburbs. And so somebody came up with an idea of why don't we put a femto base station inside the home, right? So you look at how cellular wireless has evolved. You can have a femto base station like a wireless access point that sits inside your home. And at the other end, you could have a 50-meter tall tower, which is hosting high power radios that are blasting out power. Now, so your need will be somewhere in between. Now, all of these, the femto base station, the pico base station, micro base station, macro base station were all vertically integrated black box product variants. There were different product variants, and most of the times having different software streams. That's what Open RAN has done today, that you can scale your software on choice, scale your hardware on choice, pick the radio of choice. And that's the biggest power that I see. And so that you could look at exactly what your deployment needs are, where you need to get the coverage, what capacity do you need. You might have a very high power, long range requirement, but very low capacity needs. Or you might have very low power needs, but extremely dense capacity. The femtocell was a great idea. It was supposed to cater to 4 users, a family inside a home. But very soon people started wanting that we could apply this to offices. And in some places we want 64 users. Now suddenly that's very dense capacity, low coverage. How do you handle with that? That won't fit into a Wi-Fi access point. So these are the flexibilities that we have bet on. We have focused on developing software that is scalable, that can be put on a hardware platform of your choice at Sukta, and then you can pick a radio unit. We've built an ecosystem, much like the name indicates, an open ecosystem, where based on open interfaces, we could deploy base station software on a hardware of your choice, and then you pick the radio that exactly meet your needs and rely on the open interfaces. So primarily the open interface, there are interoperability challenges. The network could be unbundled in a lot more ways. But what is really great is that the unbundling that has happened between the radio unit and the CUDU, if you disaggregate them, or as the baseband unit, as it is called, if you have integrated them. So that interface is quite mature. So we expect that the interoperability there will be manageable and it won't be very complex. So you could pick any radio unit that is compliant to what is known as a 7.2x interface, which is standardized by the ORAN Alliance. And then you could deploy your software on a hardware of your choice and build a network that gives you exactly the capacity and the coverage that you need. And then the other thing that will follow in the roadmap is what do you want to do with the network and the kind of intelligence and management that you want to apply. The use of automation, analytics, as well as artificial intelligence, that is the next thing that is happening. The standards are maturing. So you could buy equipment from multiple vendors, but manage all of them with a single platform, right? You wouldn't have to take network management from each of them and then worry about large system and IT integration as to how do I integrate all the management systems from these different vendors? How do I just manage the network end to end? So you could buy an RU from one vendor, the software from another vendor, just buy the hardware from Dell or Contron or Advantech, and then you get a management framework from a system integrator, and you could put the network together very quickly to suit exactly your requirements. And that for me is the biggest promise of ORAN and one that we are actively pursuing at Sukta. Thank you.
Thank you, Balaji. Now I turn to Balaji K from Galore for his views on Open RAN.
Good morning, everyone. So my perspective on the ORAN is today, I think the advantages of what having an ORAN architecture has been very well established here. So the biggest challenge today is the networks are not disaggregated. That is one area of concern where the ORAN vendors today are having an issue, because most of the networks are, as we pointed out earlier, the CUDUs are in the site. So that is one of the reasons where the operators want everything to be from the same OEM. So the disaggregation is very important, primarily because when we are talking about any kind of flavor, say femto or pico or micro or macro, as we deploy 5G, today we don't have enough spectrum available for 5G at the lower frequency. Maybe I call it as FR1. At FR2 level, if you're looking at deploying many base stations, you will have a problem in terms of your space as well as your backhaul. In that scenario, disaggregation of the RAN is very important, primarily because the data breakout can happen and you can take the control plane alone to the core. So this is something which has to come from the operator. Several advantages are there here today, which you can buy from multiple OEMs, off the carts, hardware, and then software from different vendors. But at the end of the day, the deployment architecture has to be redefined. You need to redefine it and then take it in a way that you can have, if you have a radio in FR2 tomorrow, what is the range we are looking at it? So we're going to have multiple radios. Personal base stations are going to be, maybe long ago there was a product which was My Base Station for 3G, which didn't take off. But this is in the era of 5G and 6G, this is going to be a major role which is going to be played with this. My personal base stations are going to be the main thing. And if you look at how we are going to integrate the terrestrial as well as the satellite networks as we move forward into 6G, the disaggregation plays a major role. So if you are going to put it on a LEO or a MEO satellites, then you are going to have multiple radios going around, and you cannot have CUDU in every satellite. So these are some of the things which is going to be the future, which we at Galore Networks we are working on. We also had the challenge of going to the vendor. We work with a lot of networks commercially. The operator starts looking at the solution if you have end-to-end. So we started with radio, then we started with the CUDU hardware, then although we had our CUDU software, so all these things started coming up. Now we have an end-to-end offering, but the future is going to be disaggregated RAN and disaggregated vendors. That will help in adoption of the technology. Thank you.
Thank you, Balaji. Now over to Parth from Tidal Wave for his views.
Thank you. Namaskar and good afternoon, everyone. I'm Parth from Tidal Wave. We build 4G, 5G radio access network, end-to-end software defined. Everyone, all the speakers, they spoke everything that is to be understood about Open RAN, the savings that it brings in terms of your CAPEX, OPEX. Our perspective at Tidal Wave is beyond this, beyond the savings that you get right now as a user, as an operator, on the CAPEX and OPEX, just the amount of innovation that you could leverage in the future. Because even telecom being an infrastructure play, you have to plan 10 years in advance. But Open RAN essentially gives you a flexibility wherein you could have an ever-evolving network, a network wherein you can change bits and pieces as in how they come. Let's take, for example, at Tidal Wave, our DU is the most efficient it could ever be. Our encoders and decoders are the best of the industry. But the rest of the system you have deployed is from other vendors, other OEMs. So taking that DU from a company like ours, putting it in that existing vast network, deploying at scale would be just matter of months over rather than, going through a process of, swapping the network or adding additional network, etc. And the reason an innovation or an innovative idea in a small unit exists is because it is either cheaper, better, or faster. These three reasons. So eventually, because of Open RAN, you will be able to have much more savings, much better quality, much efficient networks, as opposed to the static, boxes that we have been buying over the past decades as users. So that to me is a very powerful premise. Beyond that, there are a lot of other advances in AI and RAN intelligent controllers which have come across, which is not something that 3GPP was always focused on. This is where Open RAN basically comes into play. But I overall agree with the fact that the Open RAN is still a misunderstood term. Unbound RAN would be much more clearer to understand. Things are modular, flexible, and your networks can be ever evolving. That's what our perspective on Open RAN is.
Thank you, Parth. I'd like to open it up right away. If the audience has any questions, so that this becomes more focused on answering what you are thinking, rather than just our opinions. So anyone who wants to go first from the audience, what question do you have on Open RAN?
If anyone has a question, please get your mic.
Yeah. Yeah, so the question at the back there, gentlemen.
Yeah, thank you so much for the wonderful presentation. My name is Dr. Jabera Matogoro. I speak from the academia and also from the direction of the startup consumption. I know the Open RAN has come up with a lot of advantage, as you have explained, but I would like to understand to what extent do you expect the use of artificial intelligence to simplify the Open RAN in terms of spectrum management? Because I know spectrum is a very scarce resource, and some of the technologies are people adopting the use of geolocation spectrum databases. I'm not sure on how you are handling this. Thank you.
Thank you. So anyone wants to take that? How are we using, or how could one use artificial intelligence for spectrum management? Anyone has a view on this panel? Sure, Manish.
So, Art touched upon important aspect of Open RAN, right, which is the recontrol. And recontrol has got two flavors, right? One is not real-time recontrol, and which is the real-time recontrol. A lot of mechanisms on the spectrum management will get built into the real-time recontrol. And this is where the real challenge lies, right? Because there's a significant bit of latency sensitiveness to the calculation and communication that exists right now on these interfaces. And if we are able to do that, we should be able to handle the spectrum questions much better. I'll just give you an example, and this is from my previous experience coming from an operator. In India, I'm not sure if this happens in other parts of the world or not. In India, there is a phenomenon where you get the interference on the base stations from a base station which is very, very far situated, right? Like 200 kilometers, 300 kilometers away base station. The interference coming in effect, right? And this is happening into the TDD networks, right? Because everybody transmits onto the same time source, right? And what it eventually does, right, it reduces the efficiency of your base station, right? Because the way to mitigate that interference today is to basically do two things. One is that you tilt the base stations, right? The interference, right? That is interference is coming has to be tilted down so that it does not affect, it doesn't go to the space and then it affects it, right? And this has to be done in real time because you need to know who is interfering, right? Who is the source of interference. And the second way to do it is reduce the power, right? And when you do this, right, you're actually affecting the user experience in those cells where these guys are operating. And this has to be done in real time across many base stations that are happening, right? Think about a country like India. At any point of time, I've seen at the peak of this, around 8 to 10% of base stations starting to get interfered in this manner. And how do you handle it, right? this real-time calculation, for you to be able to figure out that there is an interference going to take place. First, there is an interference happening that is responding to the event. You need to be able to predict it, that interference is going to happen in such and such scenario, right? There is climatic condition, there is wind, there is cloud, there are a bunch of things that you can look at and see the interference is going to happen, and therefore you need to start to move your base stations appropriately. Change power, change direction, change the tilt and all that, right? So some of these techniques really would become, today it is being done, and I must say that it is being done by the large vendors, the vendors who the integrated ecosystem, but the techniques are all proprietary. As you open up the ecosystem, right, there will be more and more people who will come up with methods to tackle a problem of this kind, right? And therefore, and many other problems like this. Right? So my belief is that once you open up the interface, how many times the customer starts to get, some footwork, you will see a lot more innovation happening around this to tackle the enterprise spectrum utilization.
Thank you, Manish. I hope that goes some way to answering your question. But what's the next question? Sorry, okay.
Hello.
Here, there's a question in the front row.
Can I ask?
Yeah, yes.
So this is for Open RAN application on private 5G. How we can deploy Open RAN application for a 5G network, for a private 5G network, sorry. And do we have to apply a application-based software into a private 5G for the particular enterprise, like railway, for their signaling network or power or a steel plant, something. So we need to understand that.
Okay. So does anyone have a view on how someone goes about deploying a 5G private network, especially about spectrum and licensing? Okay, Balaji.
So you mean to say how the private 5G network is deployed? And top of it, applications, how it is run? That's the question?
How Open RAN will be deployed in a private 5G? That is the question.
See, the architecture is same whether it is going to be a commercial operator or a private 5G network. Okay, the architecture is going to be the same. And if you are looking at private 5G for large scale enterprises like railways or power sector, so what happens here is they are going to use it for their captive network. So in the captive network, what happens is you have to apply for the license with the government, and government are considering now to issue licenses in the 5G for exclusively captive network. You cannot use it for commercial activity. So that is possible. So for us, we are on the transport side. Any application can run on top of it.
So these enterprises have to buy a license from government, or?
Yes, and there is an option today that you can work with certain operators, and then you can enter into an agreement using the operators' spectrum to also deploy 5G private networks. So I'm sure a lot of operators are there in that
So
space.
they have to deploy a core network and then put up their application software into and integrate into that. Like suppose signaling needs to be integrated into a private 5G. So the core has to be integrated with their signaling network or something like that.
There will be two types here. Either you can go for your own core, and then you can have your own RAN, and then have an agreement with the operator to do it. That is one way. The other way, network slicing is possible. If the operators permit, operators can offer network slicing. That is another way of giving you a private network. Exclusive private network, you can go for your own core as well as the RAN. And in this, again, you have multiple vendors from our side itself who can give you core separately, RAN separately, and RAN software also. The CUDU software basically separately also.
So core will be common and RAN maybe multiple vendors like that, or maybe
Core is also a lot of people out there. We from the Atmanirbhar Bharat, from the Indian ecosystem, we have cores both on the NSA as well as SA side. I'm sure we have one, and Resonus Subaya has one, and there is neural networks, they have one, and we have CDOT have a core.
Means on the deployment perspective, if different cores will exist there, so how there, will there be any smooth integration of different, because it may be a pan-India network, it may be a large regional network. So different cores will have different integration challenges may happen. Is it?
See, at the end of the day, if you're looking at private network, you need only one core.
Yeah.
So if it is, I am sure even if you have looked at many of our tier 1 operators, there are multiple cores also exist. So it all depends on the scale of the network and how you want to have your vendors. It depends on that. You can actually have multiple core, integrate all the core together. That is also possible. At the end of the day, what is the architecture you want to deploy? Is what matters. But the complete ecosystem is unbound. Whether it is core, RAN, and RAN, again, we are talking about CUDU, the hardware, software, and the radio.
Okay, thank you.
Thank you. I think the gentleman in the front row. Yeah.
Namaskar, and I myself from Japan, Indian Association of Japan, myself Dr. Sanjay Mehrotra. So, as per our discussion, I would like to know what is the strategy for cost down you are going to take.
Strategy for
Cost down.
cost. Yeah.
Yeah,
So,
and what other and new technology you are looking for, and how to solve lower frequency problem? What you say?
so what is the last one? How to solve?
Solve your lower frequency problem,
What is the lower frequency problem?
as you discussed with the RAM and other things like recently like that. Yeah.
Okay. Anybody wants to take? How do we lower the cost in Open RAN?
Yeah, I can take
Okay,
this.
sure, Subhaya.
Okay. See, how do we make the cost down? Fundamentally, first cost will come with the R&D expense, then the equipment expense, which with the volume goes up, the things will go down. Okay. So bottom line, the ORAN is the at least as the R&D expense from these vendors, like say, is significantly lower compared to the tier 1 vendors, like where thousands of people will be working for them, all those things. The second thing is, today we have the volumes lower, which may not, but we'll offset the cost through the R&D expense, which is lower. Okay. So going forward, as soon as the more volumes come into picture, obviously like our cost will go down. Other thing, what is the major advantage with the ORAN is we can use the existing cards hardware. Like say, for example, like say, I can provide some hardware where Sukta can put their L2, L3, which in fact I'm trying to do. Okay. With this strategy, right, where I can build the equipment in bits and pieces and concentrate on that and then make sure that my volume goes up, the cost goes down. Okay. That I can answer that.
So, okay. So I didn't quite get the spectrum problem, but
Yeah.
if you're alluding to the fact where the spectrum will come from, I think either you can license spectrum or you can license it from an operator, and operators are allowed to license their spectrum for private 5G use.
Maybe I'll answer this actually. See, the spectrum is concerned, right? You look at the different geographies. The Europe, if you go for the private 5G networks, right? Hardly like say you pay like say $100, $200, a year license will get it for 100 megahertz. When it comes to India, what the government of India did is like at least through BSNL, there is something called CMPN network. Maybe someone else was asking that how do I get a spectrum? Through BSNL, if you are you want to get a spectrum, you can apply through CMPN program where they will provide a spectrum and the list of vendors associated with that. That's the easiest way to get it, in my opinion.
Okay. Okay, next question. Yes, the gentleman at the back. Thank you. So I don't know how much time the organizers have allotted. I'm going by 45 minutes. So we have another 7 or 8 minutes. Yeah, please.
Thank you very much, and what an insightful discussion. My name is Samson Sumani from Telecom, Zimbabwe. I just want to understand the maturity of this technology, and also if you can give us maybe practical cases or maybe operators or in areas where they have deployed this and the new challenges that have been encountered. Thank you.
Thank you. So the question is, what is the maturity of Open RAN technology? Can we give some examples where this was deployed and what are the main challenges that were encountered? So if anyone has experience in deploying Open RAN technologies? Okay, Manish.
Okay, so let me try. Look, OpenAI as a technology, the standards started developing with the 4G itself, right? So if we look back on how an alliance working, they started first with the 4G and then slowly migrated into the 5G. If you look at from the perspective of operator, the standards have slowly, gradually come into the existence. The equipment has been slowly, gradually, maturing itself. There are few examples that we should look at globally. There is a network in Japan by Rakuten, built completely on open cross. There is a network in US by Dish Network, built completely on the open cross. There is a network in Germany by one, which is completely open. And then the most important and significant of all is an announcement that has happened a couple of months back by AT&T that they will be deploying Open RAN, not their entire network henceforth. Right? It's a different thing that they've chosen to go with a single vendor implementation instead of disaggregated network. But really, from the maturity perspective, you can see there are commercial networks of different size and shapes are running already in the equipment. The challenge that we see for yourself is the spectrum, is the frequency ranges that you have in your region. And do you have the radio units available for those frequency ranges? The other challenge that you see is that how do you, two challenges, right? First, how do you make sure that all the equipment that you buy from different vendors is interoperable and integrated, right? That's a little bit of a challenge that was tackled much ahead of time by bringing in operators by doing different things. For example, OpenAI itself set up the interoperability labs across the globe to pre-certify the equipment. In India, we're setting up the similar certification agencies. The second challenge, which is the most significant challenge that you must see, is that how do you reskill your operational workforce to be able to handle an open RAN network? Traditionally, when we used to get a problem in the network, you would just make a phone call to the single vendor and it would come and resolve without complaining ever that whose problem is it. But when it comes to open RAN, when you segments of the network coming from different vendors, the important thing to know is that whose problem is it. When you see a problem in the network, whom do you approach and how do you get it resolved? That requires a little bit of reskilling, upskilling of your workforce to be able to handle the complexity that comes out of this. But beyond that, I don't think maturity is important. It's a little bit of evolutionary in nature, and I think it's very well done.
Thank you, Manish. I think we need to conclude, but
Thank
since
you very
Balaji,
much.
R, and Parth didn't have an opportunity to answer anything, are there any quick remarks you want to weigh in on any of the questions? Then we will conclude. Balaji?
Yeah, I think there were a number of different questions on the spectrum, on the maturity. Just talking about maturity, Manish already mentioned about Rakuten and the Dish deployments, which are all greenfield ORAN deployments. A lot of deployments happening in Germany. But one thing you also have to observe is that Ericsson, Nokia, and Samsung were the leading infrastructure vendors. They've also opened up to supplying open RAN systems, most primarily hardware and software disaggregation. You would know that now publicly, that all three vendors have solutions that are available on different hardware platforms. So already they're doing the decoupling of hardware and software, and so that itself proves the maturity of the decoupling as well as the radio interface. I think again radio units, already there are examples of Ericsson radios using Ericsson equipment using Fujitsu radios, Nokia equipment using Fujitsu radios, Rakuten networks using Nokia radios. So the equipment and radio interoperability, there are quite a few use cases where there are live networks running this kind of a mix and match. I think on the spectrum, I would like to add that AI analytics at a simpler level, self-configuring, self-optimizing networks, all of that are further enabled by the Open RAN architecture, particularly the disaggregation of the RIC into a separate unit. So you could look at the open interface, potentially develop your own algorithms or get a third-party algorithm that is better suited to your network, that optimizes the spectrum usage, as compared to having a proprietary black box and relying on a single vendor to continuously fine-tune the network to your needs. So those are a couple of remarks I wanted to add.
Thank you. Thank you, Balaji. Closing remarks from Parth.
Yes. Just building on what Manish said, I believe that the technology is there from an OEM perspective. Between us, we keep on interoperating. We go to these test beds, we do the pilots. So the technology is there as far as Open RAN is concerned. What is still in the phase of development would be the services component, wherein there are good system integrators with a lot of experience to put these things together, to make sure that the support is there, etc. So that in my view is taking some time, and that will mature with more deployments and more experience. But the technology is there and it works as far as Open RAN is concerned. And I believe this is the future. There is no other way. This has happened earlier between core and radio access network. There was a split which was not so easy, but it worked. And it's going to happen. The same thing is going to happen with RAN as well, and it will work. There is no other way forward.
Thank you, Parth. So with that, I would like to conclude this session. I thank all my panelists on the dais and all of you for your patient hearing and questions. So thank you. Over to the organizers.
Thank you. We would like to thank all the panelists for the valuable information that we shared with us, and we would like this moment to felicitate all our panelists. I request Dr. Kumar to kindly felicitate all the panel members on the dais. To begin with, Mr. Venkat Subbiah. Let's have a round of applause, ladies and gentlemen, for Mr. Venkat Subbiah. Mr. Parth Pokar. Let's have a round of applause. Please put your hands together for Mr. Parth. Gratitude to you, sir. Mr. Manish Kange. Mr. Balaji K. And Mr. Balaji Rangaswamy. I also request Mr. Arun Gupta to kindly join us on the dais to felicitate our moderator for this session, Dr. Kumar and Sivarajan. Ladies and gentlemen, put your hands together. This was on RAN Unbound, Breaking Barriers with Open RAN Networks. I'm sure this was a very informative session for each one of you. Requesting all of you to kindly assemble for a group picture. We would like to thank each one of you for sharing their valuable insights with all of us, and we will surely benefit from this. Thank you once again. Ladies and gentlemen, before we part for lunch, there are two very important announcements. You are requested to kindly drop your business cards in a bowl which is kept outside.